Thank you and welcome to Reliability BoomBox, proudly brought to you by Reliability Extranet. You're here today with Seven, or Peter Horsburgh, the author of 5 Habits of an Extraordinary Reliability Engineer, founder and CEO of Reliability Extranet and group of companies, and myself, Dane Sullivan, the business director, development director of the Reliability Extranet group of companies. And we thought we'd bring to you a little podcast, a little water cooler or fireside chat, just about reliability engineering, processing, problem solving, and tools and tricks of the trade that we thought might be helpful. So with no further ado, I welcome Seven, aka Peter Horsburgh, to the table. Hi, Seven, how are you?
I'm very well, Dane, thank you.
Excellent. So, yes, I thought we'd get started on this podcast. It's going to be a bit of a co-hosting event for you and I think occasionally we'll invite some guests along to chew the fat. And
I think we've got some interesting people. Yeah, interesting people to bring onto the podcast.
Yeah.
Awesome.
But just for everyone else listening out there, first up, we're going to try and keep this pretty quick and simple, around 20 minutes to half an hour. We'll give you a notice if it is any longer for any reason, probably when we interview someone else. But we want to really help you solve some key problems in reliability engineering. I think the space is moving quite quickly, and also just in general problem solving. I don't think we need to constrain ourselves to reliability engineering, whether it's engineering in ore, whether it's production, whether it's maintenance, even operations and automation in other fields and other spaces. So do share this post if you think it's of interest or it might interest someone else. If there's a topic that you hear someone and they like it, then certainly share it. It would be great. And any feedback is also welcome. Seven, I thought we'd get started with a little bit of why Reliability Extranet and why you do what you do, and what brings you to us.
Oh, right. Excellent. Well, I've been an engineer for 20 years, involved in reliability for 15 plus years of those 20. And essentially, the whole idea of Reliability Extranet, I wanted to create an external network of support for reliability engineers. Okay, reliability engineers like myself. Now, over my career, I've worked in power stations, coal mines, aluminium smelters, and made some mistakes along the way. Learn a few things.
We all have.
Okay. And essentially created Reliability Extranet to provide the knowledge, tools, and data to people themselves out there managing rather large things or assets as they're sort of now known, or physical assets as they're now known. And what I wanted to do was create something that brought the knowledge, tools, and data to make their lives easier. Okay, been there, done that, made a whole heap of mistakes, learnt some stuff along the way, and part of writing the book, as you can see over my shoulder here, is part of that that goal of bringing knowledge, tools, and data to people like myself. A little bit of knowledge inside a book.
Awesome. Well, I'll just share for the listeners and people out there. The reason I actually joined Seven and the team, Seven and I went to university together later on in life for business degrees, and we enjoyed working together. I think we did a couple of projects together, which were always fun.
At uni.
And when I caught up with Seven one day, I was running my yoga studio, and I caught up with Seven one day for a coffee, and he was telling me about his book that he's written, and I'd seen this come up. I'm like, I'm interested in hearing about your book because I had a maintenance background. And when I saw all the things that he was bringing to the industry, I was really blown away at how important that is, how beneficial that could be to an industry. I was very much, I left the industry initially because I was tired of beating my head against a brick wall with trying to do things differently, trying to think outside the box. I found a lot of people weren't thinking outside the box. I saw Seven thinking outside the box and doing things different, and then helping with provide these tools and tricks and elements to the industry. I thought, this is amazing. And Seven bailed me up and said, I'd love you to help me. I said, well, you're doing such a great job at bringing such a good thing to the industry that I couldn't say no. So I kindly said yes.
I gotta note that Dane could not say no.
So my philosophy in life is making life simpler for people, so I don't have to work so hard to get things right, and to keep things sustainable. So jumping in, Seven and I dove in and started working together, and we could see that I plugged a little hole for Seven in the business. And we're working towards that. And I think the great thing is that our views in the company are very important. That is about sustainable. It is about educating, training, and helping others to do things better.
That's it.
We're not about selling the shirt off our back just to make $1. It's actually about just helping people and giving people. For those that are religious of any kind, I think Jesus once said, give a man a fish and he'll eat for a day. Teach a man how to fish and he'll feed himself for life. And that's, I guess, where I come from, is that I really want to help Seven to teach other people how to fish in this space. And I think with some of these tools, we've got some great fishing rods, for
yes,
a phrase to use. So awesome. So I think diving into that, nice little segue into a couple of things. So a couple of the key items that we spend a lot of time and a lot of space in, and that I think is also a little bit new to some people, but it's also, one of them is very new to the industry, but then others have been done for many years, and we just need to look at, there's other ways to do it. So the first thing I'd like to talk about, Seven, is RCAs, or problem solving. I'd like to categorize it in problem solving. For those of you out there, RCA means root cause analysis, but really we see it as a company as more about problem solving. So it can be a problem in maintenance, it can be a problem in production, it can be a failure of an automated piece of machinery, it could be an incident in hospital, it could be an incident due to weather. I remember when I was going through the RCA training to get myself back up to speed, I did a mock RCA on a tree that fell over in my front yard due to poor weather, and established that a retaining wall wasn't suitable. Anyway, so I think if we can just talk about that problem-solving concept and why you think problem solving is so important, and why it's important to have the right tools to help us with problem solving.
Yeah, sure. So there's a whole chapter on this or a whole section actually on this in the book, and what we're talking about from the 5 habits is habit number 2, understand. Okay, so the way that I think, and the way that I've learnt, is that if you don't actually understand a problem, right? You don't actually understand a problem, you basically have no chance of actually solving it. Okay, you won't be able to do it unless you understand it, right? What's happening, and that's what problem solving is all about: is understanding a problem to a point that you can actually solve it. Okay. Now, me being an engineer, I relate well to the structured style of problem solving, because it gives me a step-by-step framework, if you would like to call it, of actually working through that process of problem solving, rather than just sort of ad hocly going, I think it could be this, because I've been there and done that and burnt lots and lots. I'm not going to say how many dollars, right? But I've been there and done that, been involved in things where we did not understand the problem and said, I believe it is this, right? And going away and committing lots of money to actually solving that, and finding that the machine actually fails again 3 months later. Okay, and that's the net result. The net result is that the problem reoccurs. Okay, how's that for your personal life or business? You know, we generally talk business, but even personal life, problems reoccurring in your personal life, it's not good. It's not good. And and that's where I think, you know, a little bit of structured problem solving goes a long way to reducing those reoccurring problems. Suffer the pain once. Learn, fix it, move on to the next one. Continuous improvement. It all fits inside that bucket and making things better. So, written a whole section on it in the book, in the 5 habits. Okay, and you know, we're you know, talking about the reliability extranet group of companies. You know, we believe in it so much. We've got a partnership here in Australasia with Sologic. We support the Sologic problem solving process here in Australia, New Zealand, Papua New Guinea, Indonesia and Malaysia. Okay, we're here on the ground helping people solve problems, and you know, not just helping them solve the problems themselves, but as you said, we're helping them with tools and training, provide that fishing rod, so that they can get out there and do it themselves. And that's what I like to do is, you know, is giving people the fishing rod to go out there and do it themselves. And providing that support and help.
Awesome. And that's one of the things that I've really enjoyed about being a part of this group of companies is the problem solving aspect. It's always been something that's fascinated me in growing up. I've always been one to sit there and think about it and work out, you know, try and understand. You know, there's a saying, seek first to understand, then be understood. But in this world, it's seek first to understand, then solve the problem.
Exactly. And if you understand it, you've got a really good chance of doing that.
You do. You have a much better chance of doing it. And I think, you know, we've all been in the situations where we've flown off the handle and just done the first thing we think of, or tried something, and sometimes that's needed. And an emergency situation, sometimes you're going to do that. What I really like about this process in general, and I guess one of my philosophies with problem solving, is when we understand and we solve from that point of understanding, it's more embedded. It's more of a true solution, and you're less likely to repeat it. You know, It may be repeated, but generally if it is repeated, maybe there's something you've missed and you haven't quite understood. That's okay. However, likely when you do understand and you solve the problem right down to the root cause, you are far less likely to repeat it.
Yes. Yeah. And if it does reoccur, you're actually moving forward with experience. You haven't actually failed per se. You've now got that experience to say, hey, this is what we thought. This is what we thought would work. Okay. We thought it would work. Why would we do it? Okay. And now it hasn't worked. Okay. And we go, aha, now we understand why it, you know, you've got more insight into why it hasn't worked. Right. Yeah. So I firmly believe, you know, it's a learning point. If you learn from your failures, okay, right? The whole idea is to only suffer that failure once, and that's what you're striving for, essentially, and eliminate that chance of that reoccurring again, okay? But if it does reoccur, you haven't actually failed. You've actually learnt something new. There's something going on that you didn't understand. You've actually got it's I'm not going to say it's a gift, but it's like a gift. It's like a gift because because there's an opportunity to learn and improve, and that's what it's all about. You know.
Yeah, certainly. And taking on the learning aspect, I think we're always learning. There's always something new to learn. And in a world where everything is go, 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 striving to get things done quicker, faster, and with less downtime, let's say that.
Mm-hmm. Pushing the limits on pieces of equipment.
Pushing the limits left, right, and center.
Yep.
And that's not just with machinery. It's with production. It's with processes. With our staff. Like, I think one thing I like to.
It's people. Yeah, people.
It's people. It's like we're pushing people to work longer hours. Whether you're a nurse, an engineer, a truck driver, we're extending your hours. We're pushing those boundaries more and more and more. And understanding when failures occur and understanding how to solve them is really great. One other thing that I guess we're leading into in the next aspect of what we do here at Reliability Extranet is machine learning. So this is one of those things that is a little bit new to the engineering and maintenance world, especially here in Australia.
Yes.
I think in the United States, they're a little bit more onto it. There's a lot more people in the United States, and there's a lot more push to get things done quicker, faster, and with less downtime. Though machine learning is here, and it's a very data-driven process. So I guess from your point of view, Seven, and from your experience, why is machine learning important? Why and what have you seen come about with machine learning from recent years? Yeah.
So it's like the technology is getting better and better by the day, right? Yeah. And the thing that I think people miss with the machine learning thing, they get all hooked up in the technology, the Internet of Things, and all those magical buzzwords that, sorry for my IT friends, but all the IT people love, okay, and the marketing people love, okay, and it gets out there, and like I've been confused myself with some of the terminology in the machine learning space, and what does it mean, right? For me, machine learning is recognizing a difference in behavior. That's it. It's a computer algorithm that recognizes difference in behavior. Okay. Now, there's a whole heap of different ways that it does that. But what is the value to me as a reliability engineer of having something recognize the difference in behavior? It's warning time. It's warning time. It's warning that something bad is about to happen. Okay. Yep. And wouldn't we all like to know that? Right. And isn't it like the Holy Grail where you could have your computer system that manages the plant, for example, recognizing a difference in behavior 10, 20, 30, 40, 50, 60 hours plus before the event actually occurs. Okay? Before the event occurs. And I've seen machine learning algorithms be taught to recognize specific events. Okay, so they're recognizing the symptoms of specific events, and the computer is now telling you, hey guys, you've now got 10 hours before this hose clamp falls off. Okay, and it's doing it. The computer is recognizing the symptoms, right? And when you go back and you test it and all that sort of stuff, it's getting 90+% accuracy.
Yeah, wow.
So imagine that in your plant, a loose hose clamp, which could potentially stop your machine, getting, I'm recalling a specific example here, 29 hours of warning before the event actually occurs and the machine stops due to an alarm. How awesome would that be? And that's what machine learning is all about, is that warning time, giving you the heads up that something is about to happen. It's learnt, you teach it, for example, or it's self-learned. Some of these things self-learn, and getting that warning time. And that's what the crux of it is the machine learning recognizes a difference in behavior to give you that warning of that something bad's going to happen.
Yeah. 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 Awesome. And I think one of the things that I've seen on sites and a bit of the pushback is, I remember an instance a few years ago. I was at an engineering conference, and this was quite a few years ago, but a lady stepped up and started talking about automation and automated controls, and was very direct about how the industry is changing. And for a lot of these engineers that were sitting in the conference, a few of them were a little bit older, the more mature age, that had worked in the industry for quite a number of years and had a number of peers that were in that industry. And the initial red flag came up that people are going to be out of a job. People are going to lose their job because all of a sudden a robot's doing their job for them, or machine learning, because that's what we're talking about, is going to process that. So I guess with reliability engineering, when we talked about this initially, I see that this machine learning process can really do part of what a reliability engineer's role is to detect problems through data. Through condition monitoring and through information that comes in. However, what I've started to see, and I think what I really want to remind people of, is that think about how busy we are. Think about how pressured we are. When I've sat in the job of a reliability engineer for teams, there's been an influx of information coming at you. There's a problem solving. There's a breakdown every other day. There's something that you have to solve. And then there's an RCA that you need to do. There's leadership training that you need to do. There's a general reporting that you need to do, and all the other information that takes up a lot of your time. And then when you got to deal with a breakdown, you're like, oh, damn. Or as my daughter would say, biscuits. And it's like...
That's Australian.
Yeah. So I think what I've started to see with this machine learning process is it really actually empowers people to get ahead of that game, to really identify these problems before the truck alarm comes in. Like, that was a really classic instance. I remember the incident you're talking about, that we pulled the data out off this truck. Straight away, it picked up information. The alarm was here. We could have first up notified it 6 hours before, and then diving a little deeper, we notified it 29 hours before. In that 29-hour period, there was an in-pit service on this machine, which meant that a technician that was going to the machine anyway could have tightened up the clamp, and the machine could have kept running. So typically when the alarm goes off, the machine has to go down, has to be brought in. So that team of people that are servicing that machine, or servicing another machine, I should say, are taken off that machine to repair this particular machine that has come in, that's now out of production, fix it, and then send it out. Whereas it could have been a 5-minute job and other people were still doing their thing. And it's not taking away from people doing things. It's not taking away. It's really just empowering people to do their job better and do it easier.
Exactly. And I totally agree.
And that's where I think these two things that we've talked about here with the machine learning and the problem solving are really two key aspects of engineering, of maintenance, of production, of warehouse automation, of hospitals. Like, you think anything that there's a process, anything where there's an actual procedure, and whether it's automated, whether it's done by a machine or whether it's done by a human, there's steps. Like, we're all guided by steps now. Like, I started my working career at McDonald's, like many of us probably did, and there was a process to making a cheeseburger. It was quite simple, but there was a process, and every single time you followed it. The buns went in at a certain time, the meat went in at a certain time, and the sauce went on in a particular order. That was it. But it was a process. And if you're talking about solving a problem, you can even dive into that process of making a cheeseburger, and you could probably improve it, through problem solving.
Mm.
Yeah, there might be a way to cook the burgers quicker if you had more data on the cooking process and times, or how long it takes to do the process. Though I think that's where, for us, we're really trying to dive in. That's what we want to share here in this space and with everyone. So it's not just about maintenance. It's not just about reliability engineering. It's about problem solving in general, and how the likes of machine learning, root cause analysis, even oil samples. Like, I think throughout this podcast, I think we'll dive into all those different things. Yeah.
Tools. These are essentially a toolbox for people to use. And I'm not just talking about reliability engineers. I'm talking about people that want to improve.
Yeah.
You know, personally, they want to improve. Business wants to improve. Whatever the driver is, doesn't matter. For us, it's a tool set. And I'd really like to get people on here too, Dane, that have actually applied the tool set and can tell us some stories about their experience in applying different tool sets, and how it worked, what worked, it didn't work, and what we could have improved and what we learnt and all that sort of stuff along the way. So awesome.
Yes, certainly. I think it will be great to have people on here that have done that, use the tools, use the information and their knowledge to improve and to change their business, or even just their life in another way. So awesome. Well, thank you very much, Seven. I hope that was helpful to everyone else out there, and we certainly look forward to seeing you again. As always, like us, add comments, send us messages. You can find all our information at reliabilityextranet.com or sologic.com as well. So if you have any questions, queries, please reach out. We're also on LinkedIn, and you'll see some information in our show notes. Thank you again, Seven, and we look forward to next week, where we will have another little chat about more about machine learning, more about problem solving, and just being extraordinary reliability engineers.